Welcome to our video. Pine forests are a treasure trove of resources, offering a much wider range of products than the commonly known pine wood and pine nuts. One of the lesser known but highly valuable products from pine trees is pine resin. In today's video, we will explore the fascinating process of harvesting pine resin, its various uses, and how resin differs from other tree secretions, such as API. Pine resin is a thick, sticky substance secreted by pine trees as a natural defense mechanism. When a pine tree is wounded, it produces resin to seal the wound, protect against pests, and prevent infections. This resin, which resembles the sativa rubber tree, has been harvested for centuries due to its numerous industrial applications. Unlike timber, which requires the tree to be cut down, harvesting resin allows for sustainable use of the tree over many years. This sustainable harvesting makes resin an economically viable product, especially during the decades-long growth period required to cultivate high-quality pine wood. Pine trees are perennial, meaning they live for many years and continuously grow. This characteristic allows for multiple harvests over the tree's lifetime, contributing to both environmental sustainability and economic profitability. Typically, it takes about 35 years for a pine tree to mature enough to yield the highest quality timber. However, during these years, the tree also produces pine nuts and resin. Harvesting resin and nuts provides an additional income source without harming the tree, ensuring the forest remains intact while still being productive. The process of harvesting pine resin involves several careful steps to ensure maximum yield without damaging the tree. The first step is to select suitable trees based on their size, health, and resin potential. Once selected, the outer bark of the tree is carefully removed to expose the cambium, the layer of tissue responsible for producing resin. This is done with precision to avoid unnecessary harm to the tree. After the tree is prepared, a small incision is made in the exposed cambium. This incision, often referred to as tapping, stimulates the tree to secrete resin. To guide the resin flow, a V-shaped metal or plastic trough is affixed to the trunk, just below the incision. This trough channels the resin into a collection container attached to the tree. By controlling the flow and preventing the resin from spreading across the bark, harvesters ensure a clean and efficient collection process. To further encourage the production of resin, harvesters often apply a special chemical solution to the wound. This solution, typically containing substances that irritate the cambium, prompts the tree to produce more resin in response. The resin then slowly seeps from the cut, hardening as it is exposed to the air. Harvesters regularly return to the tree to collect the hardened resin and scrape away any new layers that have formed. The process of making new incisions and applying solutions is repeated, allowing for continuous resin production over many years. Once sufficient resin has accumulated, it is carefully collected and stored in containers for transport. These barrels are then transported to processing facilities where the resin is refined. The resin refining process begins with melting the collected material to remove impurities such as bark, insects, or other debris that may have mixed in during collection. This melting is often done in large vats or kilns, where the resin is heated to a point where it becomes a thick liquid. The impurities, being either lighter or heavier than the resin, can be separated out. Some facilities use filtration systems to ensure the removal of even the finest impurities. After being melted and filtered, the resin undergoes a dehydration process to completely remove any remaining water content. This step is crucial because excess moisture can negatively impact the quality and stability of the final product. To achieve optimal results, processors must carefully control both temperature and humidity throughout the dehydration process. This ensures that the resin becomes not only more concentrated, but also purer, enhancing its durability and performance for various industrial applications. Additionally, this process helps the resin achieve a consistent composition, improving its usability in a wide range of different products. Pine resin has an important application in the extraction of turpentine oil. The extraction process begins with collecting resin from pine trees, typically scraped directly from the tree trunks. After gathering a sufficient amount, the resin is placed in a distillation vessel along with water and heated with a strong heat source, such as a gas torch, to ensure the temperature reaches a high level. As the water boils, the resin melts, forming a liquid mixture. Over several hours, the turpentine oil gradually separates from the water, forming two layers: the oil layer on top and the water layer below. After about 5 hours, the distillation process is complete, and the mixture is transferred to a separating funnel to easily divide the two layers. The water is removed, and the pure turpentine oil is collected and stored in small containers. Once refined, the turpentine oil is gathered and poured into bottles or storage tanks for preservation and transportation to its destination. In addition to resin, pine trees provide other valuable products, such as pine nuts and pine cones. Pine cones, which protect the seeds of the pine tree, are harvested when they are mature. Once collected, the cones are dried to facilitate the separation of seeds. This drying process is essential for ensuring that the seeds, also known as pine nuts, are of the highest quality. The pine nut processing process involves several complex stages to ensure the product meets the highest quality before reaching consumers. First, the pine cones are thoroughly dried and then transported to processing facilities where any impurities and debris are completely removed. Next, the cones are cracked open either by machines or manually to extract the nuts inside. These nuts are carefully sorted based on size and quality to meet market standards. Finally, the pine nuts are carefully packaged and shipped worldwide, where they are highly valued for their unique flavor and high nutritional value. Additionally, pine cones are also used to make jam combined with berries. This process involves several simple steps, but it requires patience and care. First, the berries and pine cones are carefully selected, with any damaged ones discarded, and then washed under water to remove any dirt. Next, both types of fruit are boiled in water to soften, combined with sugar in the appropriate ratio. This cooking process helps release the flavors and essences from the fruit while thickening the mixture. Once the desired consistency is reached, the jam is cooled and poured into sterilized glass jars. Finally, the jam is sealed tightly to preserve its flavor and used gradually. Jam made from berries and pine cones is not only delicious, but also highly nutritious, offering a unique natural flavor. Thank you for taking the time to watch our video. We hope the knowledge about pine resin and the harvesting process has given you a deeper understanding of the immense potential and economic value of pine forests, not only in the timber industry, but also in many other valuable products. Don't forget to hit the like button and subscribe to support us and to ensure you don't miss any exciting videos in the future.